My name is Nurul Huda Mahmood. I'm from Bangladesh and I'm working here at the 60 Flagship as a senior researcher. My focus area is on industrial communications, on dependable communications, and the main application of this area is industries. So basically, manufacturing industries or other Industry 4.0 areas or other Industry 4.0 applications. Previously, before coming here to Oulu, I was working very closely with Nokia in Aalborg. So at Aalborg University, I was an external research collaborator for Nokia Bell Labs there. I did my PhD from Norwegian University of Science and Technology, NTNU, in Trondheim. After that, I was in Aalborg University for close to 6 years, working first as a postdoc and then as an associate professor. When I heard about the 60 Flagship program, I was really motivated and excited to apply for it because at that time it was the world's first 60 research program. And I really saw the potential that this was very futuristic, and at that time in 2018, it was, 60 was not even heard of. So that's really why I was motivated, and that's why I applied to this position, even though Oulu and Finland is a very cold country. Yeah. At 60 Flagship, I'm working on critical machine type communications, and in particular, ultra-reliable low-latency communication services. So the objective of this research is to develop wireless technologies that can enable very highly reliable and very fast or very low latency communications. Such communications are required in many sectors, for example, industries, or in very high quality audio, or also in, for example, vehicular technologies or self-driving cars, what we call these intelligent transportation services. One of the focus area of my research is to develop solutions or algorithms that are intelligent and that can somehow predict what will be the radio conditions or what will be the requirements in the future. And by future we mean like within a few time slots ahead, and then it can somehow proactively allocate resources with this after following this prediction. So in this way, we'll save time in the resource management part, in the resource allocation step, and also it will somehow enable quicker connectivity. Most of the solutions that we have now are reactive. That means it observes the environment, and then after that it somehow takes a decision based on this observation. These are of course good and these are applicable or useful in some of the requirements that we have today. But if you need very highly dependable communication, if you need very high quality of service, the time that is spent in reacting to the environment, that somehow slows down or that somehow incurs a delay. And we can remove this delay by having proactive solutions that predicts or that somehow tries to look ahead and see what will be the environment a few steps ahead, and then it can allocate resources or take some actions based on this prediction so that you save time in the reaction. And also, of course, we need to have very highly reliable solutions, so you need to build in some sort of diversity or some sort of contingency measures in the solution so that it can, so that the solution is highly reliable. In wireless communications, we know that once in every 10 years, so every decade, there's a new generation. 5G was introduced in the 2020s, and therefore, following this experience of the history that we have had for the previous 5 generations, we expect that 6G will arrive in the 2030s. So we can say that there's some business demand for 6G following this trend. At the same time, the ecosystem of wireless network, they develop over a bit slower time. So basically it takes around 20 years for the ecosystem to develop. And we have seen such a, let's say, a transition with 5G. Up to 4G, the main focus was mobile broadband, or delivering high-speed internet or high-speed services for people. But then with 5G, we saw the introduction of multi-service communications. Basically, there were 3 different services. So one is the extension of mobile broadband. The other is massive machine type communications, which was introduced to cater to many IoT devices that we are seeing now in the smart society that are being placed everywhere. And then the third service is ultra reliable low latency communications, or URLLC. And this was targeting critical verticals like industries, or like intelligent transport services, and so on. So with 5G, this was the first step, but of course the solutions that were there in 5G, or that are there in 5G, these solutions they are good, but they're not good enough to meet the demands of the verticals or of the applications. So naturally, we need to have new and novel technologies that can meet the requirements that will not be able to met by 5G technologies. At the same time, of course, as the society develops, or as we move towards 2030, new requirements will also emerge. And therefore, we need new technologies that can support or that can meet these requirements. So in my opinion, I think these are the main, let's say, reason why we need 6G. The multi-service communication that we saw that was introduced in 5G, it will become mature in 6G era. So in 6G, we'll have even, let's say, broader aspects of this multi-service communication. So far, we have been focusing on the link level, so that means from point-to-point communications. But in the future, we are trying to extend our work to an end-to-end perspective. That means looking at the source application, starting from the source application until the destination application, and then trying to provide dependable connectivity from one end to the other end. Of course, then the research challenge becomes a bit more complicated, because now you have multiple hubs involved, and you also may have different networks if the end-to-end communication is far apart. So that's an extension that we see that we are trying to look into in the future. So basically, to have a broader picture, or a bit holistic picture of the communication.